we're going to find a linear model for the points 2, 5, and 9, 3. Linear model would be y equals mx plus b. We get the equations 5 equals 2m plus b, 3 equals 9m plus b. You should understand this. I shouldn't need to explain it, but of course, if you're in class, you can ask, and if you're someplace else, you can email me and ask. But this is something we did and you should understand. So the first equation minus the second equation gives us 2 equals negative 7m, so that m equals negative 2 sevenths. And then we could substitute that back in and find b. Now, we're going to use matrix reduction to do this. This matrix I have written here we call an augmented matrix. Augmented is like demented except with augmented matrix. And you should know what the word augmented means. If not, you might want to look it up. And the augmented matrix, well, if we put these equations in the form, this equation could be written 2m plus b equals 5. This equation as 9m plus b equals 3. Okay, then we just write the coefficients down. The coefficient of m here is 2. The coefficient of b is 1, and 5, of course, is its own coefficient, I guess. And let's not be too picky about the terminology. And then 9m plus b equals 3. The coefficients are 9 and 1, and your right-hand side is 3. Okay, so we put the right-hand sides down here. We put a dotted line here to remind us that this is the right-hand side of the equation, and here's the coefficients of m in this column, here's the coefficients of b in this column. Now, we're not going to do matrix multiplication or anything like that. We're simply going to do something very similar to what we did over here. As a matter of fact, we did the first equation minus the second. Well, we're going to do the first row minus the second. What do we get if we do the first row minus the second? Well, obviously, 2 minus 9 is negative 7. 1 minus 1 is 0. 5 minus 3 is 2. Now, you can see clearly that this represents this equation here, which we can easily solve for m. Now, I haven't done anything with the second equation, so I'm just going to repeat it, but I've replaced the first equation with the first equation minus the second. Now, I come over here, and how do I solve this? Well, I take negative 1/7 of both sides. Now, you might think, well, I divide both sides by negative 7th. I want to think multiplication. Same thing as multiplying by negative 1/7. So I do the first equation multiplied by negative 1/7. And if you really want to think of dividing the first equation by negative 7, that's valid. But I prefer to do it with multiplication and fractions, just to keep the method as constant, as uniform as possible. Okay. And that's not a big deal. Like I say, if you want to divide by negative 7, go ahead. And the second equation is still untouched. So what happens? Well, the first equation becomes 1, 0, minus 2/7. Now, what's that mean? Well, that's the coefficient of m, that's the coefficient of b, and that's the right-hand side. So that this equation stands for 1m plus 0b equals negative 2/7. And you should see very easily that that's the same as just saying m equals negative 2/7. If you don't see that, be sure to ask. Second equation is still 910, and it's not 910, it's 913, so I'm going to fix that. Okay, I've made some changes because I had 0 here and then I used that, and I just wrote the 0 down without thinking. But this is 913, this is 913. So now if I do the second equation, the second line, 913 minus 9 times the first equation, what happens? Well, minus 9 times the first is 9, 0, 18/7. So let's see, minus 9 times the first would be negative 9, 0, 18/7. If I add that to the second equation, which is 913, the negative 9 takes care of the 9, giving me 0. That's why I chose to multiply by negative 9. I want to get 0 here. And then the 1, of course we have 0 here, so 1 minus 0 is still 1. And then 18 sevenths and 3. What's 3? 3 is 21 sevenths. 21 sevenths and 18 sevenths is 39 sevenths. So now my second equation becomes 0m plus 1b equals 39 sevenths. B equals 39 sevenths. Okay? So my goal in doing all this is to get this 1, 0, 0, 1 matrix, which gives us m, no b, equals something. The second, no m and 1b equals something, so that we can immediately translate this back into equations and write the solutions for m and b. Your task will be to do the same with a quadratic model for these 3 points. Okay, now you should probably think about just what that's going to entail. You want to first write down the equations. Then you want to translate the equations into lines of the matrix. There are going to be 3 equations because you've got 3 unknowns. You're doing a quadratic model. And the matrix that you're going to get is going to have 3 coefficients and then a right-hand side. 3 coefficients, right-hand side, and so forth. And your goal is going to be to reduce that matrix to this form, with 1, 0, 0, 0, 1, 0, 0, 0, 1 here, and whatever numbers come out here. Because then that's going to give you the values, the solutions, the values of the 3 parameters.